Hello children, welcome to Akshara IT Foundation. So today we are going to see the continuation of last chapter, that is a vector. In the last class we have seen their types of vectors. So we have completed up to orthogonal vectors, the vectors which are perpendicular to each other. So they are said to be the orthogonal vectors. No? So now position vector also we have seen there. Then here now today we will see the angle between the two vectors. Then we will be start the exercise and concept based questions then. Okay. So to find out the angle between the two vectors, the angle between two vectors. So let us take here a vector a bar is like this, and b bar is like this. This is a b bar. Now, so to find out the angle between any two vectors, it is a condition that the starting point of the vector, or we can say head, or the tail or the head of the two vectors has to be intersect each other, coincide each other. Okay, then this is the angle. We can find out the angle here. Suppose if a vector is like this, a bar vector, and b bar vector is like this. Suppose this is a bar, and this is a b bar there. So, and this is angle is given. Suppose here 30 degrees. If that is the 30 degrees. Then here we should find out the angle between those two vectors. So this has to be replaced like this. So we have to, without changing the position and the magnitude of this vector, we have to place these two starting points of the two vectors should be in the same. So parallel vector we should take there. Let us consider this is a I cap, a bar, this is a bar, and the same vector I can place here like this, without changing the direction and the magnitude there, If it is extended like this, it has extended there, this is the 30 degrees, and this total is what there? Total is 180 degrees, no? Now this one, total is 180 degrees, and what is this angle here now? So this angle will be this one, angle between the two vectors, this angle will become 180 minus 30 degrees. 180 minus 30 degrees, that is the, how much you get there, 150 degrees will get there. So 150 degrees. Like that, we can find out the angle between the any two vectors there. Okay. So this is the angle between the any two vectors. Suppose, let us see here, this is a coordinate system. Let us consider this is the east direction and this will be the north direction. And vector a bar is like this, and it is making with anti-clockwise direction like this, certain theta angle, and this one it is 90 minus theta we can add there. Okay. So now if this angle is making with this one, so it is north of, so if we can write here, this vector angle of that in anti-clockwise direction it is moving now. Okay. So this direction of this vector can be said to be north. So north of east. So north of east. So this we can write here. This vector is given like this one. It is moving in theta angle. So north of east. So this theta angle north of east we can add there. North of east means it is moving towards north. North of east, from east to north it is moving there. North of east we can say, and this is 90 minus theta. 90 minus theta is east of north. So here we can write there, this is east of north. So like that we can find out the angle between the two vectors. So now we will see the concept based questions. Page number here 63. Ordinary laws of algebra are applicable for. It is a scalar. Scalars we can write ordinary algebraic laws we can apply. So graphical representation. Graphically a vector is represented by a line. Option A we can write it is 1. And second one is given here, third one. If two vectors have same magnitude and direction, they are said to be equal vectors. Two vectors have same magnitude and direction. So they are the equal vectors. Option 2. among the following, which is not a scalar? Among the following, which is not a scalar there. Here the options are given here, 20 kg, 15 meters, 40 seconds and 13 meters due north, which is not a scalar. So 13 meter due north. Here the direction is mentioned. So that is the scalar. It is not a scalar quantity. So remaining all are given here magnitude. Okay. So they are the scalars. Fifth one here, the vector whose magnitude is 1. That is called the, it is a unit vector. Vector whose magnitude is 1 is called the unit vector. Okay. Vector whose magnitude is 0 is called the null vector. So sixth one is the null vector. The angle between east and northwest. The angle between east and northwest. Okay. I will show in the diagram this seventh one. Concept based questions, seventh one. So here it is given there, angle between east and northwest. So this is the direction. No? We can say it is x-axis. Positive x-axis is east and positive y-axis is north. This is the north and this will be the east. X is east and negative x-axis is the west. Negative x-axis is west. We can write here, and negative y-axis is south. So what they are saying here, east, the angle between the east and northwest. So this is the east, no? This will be the east here. This is the east and northwest. Northwest means it is like this, no? This is the north and west. Northwest is like this. Now what is the angle here? This here you can see there. This is the northwest means this angle exactly it is 45 degrees. This will be the 90 degrees, no? Northwest means exactly we should take middle. So the angle between north and the west it is 90 degrees. North and the east is 90 degrees and west and south it is 90 degrees. No. So then northwest, this is northwest is nothing but 45 degrees. It will make there and this is a 90. So now the angle between east and the northwest. Now this total angle. This total angle is nothing but how much it will become there? 90 plus 45. This is the 135 degrees. 135 degrees. So option is what then? Option 3, 135 degrees. Okay. Now, eighth question you see. Two vectors have same direction but different in magnitude. Two vectors, same magnitude and different in magnitude. That is a null vector. It is a negative vector. Okay. The vectors whose magnitude is equal to same magnitude but they are in the opposite direction. So they are said to be the negative vectors. Two vectors have same direction but different in magnitudes. So here that option not given, the null negative vector is not given there. So options are given here, unlike vectors, null vector and negative like vectors and non-coplanar vectors there. So we can say here magnitude are different, they have the same direction. The vectors are which are in the same direction, they are said to be the like vectors. No. So option is 3 here. Eighth one is option 3, like vectors. So a vector of magnitude 6 unit along negative y-axis, there. 6 units along negative y-axis. So this is ninth one. This is the seventh one. The vector 6 units along the negative y-axis. Negative y-axis means this is the negative y-axis. No, this is the x-axis. It is the y-axis, positive y-axis, and this is the negative y-axis. And a vector is along 6 units along negative y-axis. So then this vector, let us consider here a bar is equals to minus 6 j cap. We should multiply to get the vector form. Magnitude has to be multiplied the unit vector along that direction there. So along the negative y direction, the unit vector is what there? Minus j cap, no? So this is the vector will get there. That is the minus 6 j cap is the vector. Now 10th one, a person moves 4 meter due north and then 4 meter due east, then direction of the displacement from the original position is. Direction of the displacement from the original position. Okay. We'll write here. 10th one. A person moves toward 4 meter due north. A person moves 4 meter due north. So 4 meters due north. This is 4 meters. This is the north. No? And then next 4 meter north, then 4 meter due east. This 4 meter due east there. So this is a 4 meter due east. So this is a 4 meter due east there now. So now here the displacement vector they are asking there. This is a and B. Here we can write here this is a C. This is C. Okay, now what is the direction? A to C. No, A to C is this one. This will be the displacement. No, AC. It is which direction? Northeast direction. No, it is northeast direction. So displacement is AC. AC. A is the initial position and final position is here C there. A to C is moving there. So then the direction is what? The northeast direction we can say here. So option is 3. Option 3 we can add there. Option 3 is the right answer. So now exercise problems. Exercise problem. It's completed, no? So exercise first one we'll see there. Exercise 1. Exercise 1 there. So among the following quantities, which one is a scalar? Among the following, which one is a scalar they are asking here. So 18 meter due west, 20 meter due south, 30 meters and 23 meter due north. So third one is the right option there. So because it is a scalar, only the magnitude is given there. In the remaining, there are they have given there. The remaining they are given the magnitude and the direction. So it is a scalar quantity is 30 meters. A vector of 10 root 2 units in xy plane is a vector 10 root 2 in xy plane is. So that vector they are asking there, okay. So second solution. So this is a Cartesian coordinate system. No? This is x axis and this is a y axis. A vector is there 10 root 2. So this is a 10 root 2. 10 root 2 in xy plane. This is a x and y plane. No? Okay, then now what is that vector? So we should find out the vector there again. So this is, if this is a 10 root 2 means, we will get this is a 10 and this is a 10. No? So vector, let us consider this is a bar. A bar means, we will get here 10 I cap plus 10 j cap. 10 I cap plus 10 j cap. Okay, like this we can find out there. Hypotenuse is 10 root 2. So here this is the 10 I cap plus 10 j cap we can add there. Here the magnitude of this vector here square root of this one only, A only will get no here. So 10 square plus 10 square, 2 10 square, square root of 2 10 square. Okay. So 10 square will be come out there, 10 into root 2 will be there. Okay. That is the answer. And third one, the magnitude of vector 5 I cap plus j cap minus 2 k cap. So third one is given here. Vector magnitude of this vector 5 I cap plus j cap minus 2 k cap. So what is the formula of the magnitude of the vector? Modulus of this one. Okay, this vector here we can write here. This is 5 whole square plus 1 square plus minus 2 whole square. So here we can write there. This is a 25 plus 1 plus 4. How much you get there? So this will be the 5 and here it is 25. It is a root 30, no? Root 30. So root 30 will be the answer. So therefore the option is answer option 3. Option 2, sorry. Option 2 is right answer. Okay. It is not able to see there. So here this is root 30. So therefore modulus of a bar is equals to root 30. So this will be the root 30. So next, fourth one. If a vector is represented by 0.5 I cap plus 0.8 j cap plus c k cap, then the value of c is. Okay. Fourth problem. Fourth one, a vector is represented here, fourth solution. So A bar is given here 0.5 I cap plus 0.8 j cap, 0.8 j cap plus C k cap. So if it is a unit vector, they are saying their unit vector is represented by this vector. So A bar is a unit vector. If this is a unit vector, then the magnitude of that. So we can write here A cap. So A cap is, this is a vector, then A cap is equal to 0.5 I cap plus 0.8 j cap plus C k cap we can write here. Magnitude of this is equal to 1 there, is equals to 1. Magnitude of that value will be 1. So magnitude of this vector, how can you write there? Previously we used formula, that is 0.5 whole square plus 0.8 whole square plus C square is equals to 1. If you do squaring on both sides, we will get there 0.5 means 0.25 will get there here plus 0.64 will get plus C square is equals to 1 will get there. So 0.25 and this one, how much you get there? 0.89 plus C square is equals to 1. So from this C square is equals to 1 minus 0.89. So how much we get there? 1.0. So we'll get here 1. So 0.11 will get now, therefore. So this is 0.11 will get. So from here C is equal to square root of 0.11. Therefore C is equal to, answer is 0.11. 0.11. This is the answer. So next, fifth one, the magnitude of a vector cannot be. Magnitude of a vector cannot be negative. Magnitude of vector cannot be negative. So answer is fourth option. Fifth one is a fourth option. Magnitude of vector cannot be negative there. Always it is a positive there. We should take here modulus, no magnitude is modulus. Modulus means when the negative value also we will get the positive value. Always it is a positive or 0 or unit 1 will get there. So here they have given there not B. Magnitude of vector cannot be. So cannot be negative. It cannot be negative there. So sixth one is given here. If a vector is represented is Ax I cap plus By j cap plus Cz k cap, then magnitude of this vector will be magnitude of that vector. Same formula here we have represented. So here the sixth one it is given. So there is a vector is given like this, A bar. So the given vector you can consider here, sixth one. The sixth one we can write here A bar. A bar is equals to Ax I cap plus Ay j cap plus Az k cap. Az k cap. So magnitude of this vector. So magnitude of that vector A bar, or we can say A is equals to square root of here Ax square. The squares of the coefficients of the sum of the unit vectors. Here squares of the this one. Sum of the squares of the coefficient of the unit vector along x-axis, y-axis and z-axis. Okay, so here plus here ay square, az square. So this is a formula for the magnitude of the given vector. Seventh one, the position of particle in a rectangular coordinate system is 2, 3, 5, then its position vector. So here in the coordinate system, there is a point is given there in the coordinate system. Let us consider this x-axis and y-axis, and it is a z-axis. Let us consider y-axis. So from here any point is given in this, any point is given like this. Here a point P. That point P is given here 3 to 3 comma 2 comma 5. So means this is a 3 here. And now the perpendicular distance from the z-axis, this is z-axis. So this is a 5 we can write here, and the perpendicular distance, this is a 2. Okay. So now this is the point. Position vector is nothing but this is a r. R bar is equal to how much there? So that we can write here. R bar is equals to, so this one 3 I cap now. This is a 3 I cap. 3 I cap from here to here. And this one j cap plus 2 j cap. And next one is plus 5 k cap, plus 5 k cap. This is a position vector notation. Position vector notation. The expression here, eighth one is given. The expression is given here. Here a vector is given. Let us consider there is a bar that is equals to 1 by root 2 I cap plus 1 by root 2 j cap. So what is that expression there? Okay, what is that vector? So what can we write here? The vector which makes 45 degrees with the x-axis. Okay, so here we'll get there. This is a unit vector, no? Suppose if you find out here magnitude of this vector, we'll get what there? 1 by 2 plus whole square means 1 by root 2 whole square. 1 by root 2 whole square will get there here. So we'll get what there? 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2 is nothing but 1 only, no? There is nothing but 1 only will get there. So magnitude is equal to 1. If magnitude is equal to 1, we can say it is a unit vector. So unit vector. Unit vector. And it is making a making a 45 degrees with the x-axis, x and y-axis, So there is no z-axis because there is no z-axis now. Only the component of this one x-axis, along x-axis and along y-axis only there. There is no z-axis. So there is a unit vector in the given option only. Unit vector. It is the unit vector. This is the answer. Option 1. Option 1 is right there. So now ninth one. Identify the correct option about a vector I cap plus j cap. It is a unit vector. It is a null vector. It is a vector with magnitude root 2. It is the magnitude root 3. So here the vector is given the ninth one. Same like this only. Ninth one. So here a bar. Consider the given vector a bar, that is I cap plus j cap. I cap plus j cap. So what we can write here? If we find out the magnitude, how much we get there? Square root of. So 1 square plus 1 square plus 1 square. It is the root 2. 1 plus 1, 2, no? Root 2. So that is a root 2 there. So vector with magnitude root 2 is correct option. It is not null vector, it is not a unit vector, and it is not a magnitude of 13, root 13. So that is the answer there. Next 10th one we will see here. 10th solution you see. A person moves 8 meter due north and 9 meter due east. Then direction of this displacement from the original position. Okay, already we have done no, this one. A person move 8 meter due north, 8 meter due north, then from here 6 meter due east, 6 meter due east, and here 8 meter due north there. Then they are asking here 9 meter due east. This is a 9 meter due east there. Okay, so this is the northeast direction. No? So now the direction is what here? So consider this is a A and this is a B, and here it is C. Towards east now is moving there. This is what there, northeast direction, no? Northeast direction there. So direction of the person is northeast direction. Next, 3 vectors along coordinate axis represents the adjacent sides of a cube of side B. Then the unit vector along its diagonal passing through its origin. Okay, the unit vector along its diagonal passing through its origin there. Okay, so 11th one we'll see. If 3 vectors along the coordinate system axis represent at sides of a cube there. So this is the cube, no? This is the cube there. So side of the cube is here, side of the cube is A. Along the x-axis and along side of this also along y-axis is j cap, and along z-axis also it is along z-axis it is k cap. So k cap there. Now the vector. So what they are asking there? The unit vector along its diagonal passing through the origin there. Okay. So now the vector form. here we can write r bar is equals to a I cap plus a j cap. This is a diagonal, no? Plus a k cap we can write there, a k cap. So now unit vector, what can we write here? This one is modulus of a bar divided by modulus of r bar divided by modulus of r bar we can write here. This is a I cap plus a j cap plus a k cap we can write here. This is a k cap divided by square root of a square plus a square plus a square we can write, that is equals to, so a will be come out now here, so a I cap plus a j cap plus a k cap divided by root 3 into a, root 3 into a. So from here if you if you take the common there, so here a cap r bar cap r is equal to here a, if you take common there, I cap plus j cap plus k cap divided by root 3 a we can write that, a will be cancelled, therefore the unit vector along the diagonal of the cube passing through the origin is this one, will get there. So this is the answer, I cap plus j cap plus k cap, I cap plus j cap plus k cap, so divided by root 3, I will write here, so r cap is equals to I cap, the final answer j cap plus k cap divided by root 3. So this is the final answer. Okay. 12th one, a vector of magnitude 2 units along z axis. Magnitude along z axis. So we can write here 12 k cap, no? 12 k cap. If a bar, b bar, c bar represent the three sides of an equilateral triangle taken in the same order, then find the angle between a and b. Then find the angle between a and b. 13th one we'll see here. So this is the 11th one. This is the 11th solution. This is the 11th one. And 12th one is here. 12th one, 12 k cap. Along the x axis, 12 k cap. So along the z axis they are saying, no? If a vector is 12 units along the z axis, then the vector is, we can write here a bar is equals to 12 k cap. 12 k cap we can write there. Now 13th one. 13th one. ABC represents the three sides of equilateral triangle taken in the same order. So like this. So this is a A and this is a B and it is in the same order like this C if you take that. So A bar, B bar and C bar. A bar and B bar and C bar. So then they are asking here three sides of an equilateral triangle. Equilateral triangle they have said there. So equilateral triangle means the angle between the each and every side. So here we can say this is a bar and this one is a, okay, this is a B bar vector and here we can consider this is a C bar vector. So now here we can write this is a bar vector and this will be the B bar vector and this is a, it is a C bar vector, this is a bar vector. Okay, if this angle here this one, if this is a 60 degrees and if this is 60 degrees, if this is 60 degrees, then in the equilateral triangle that is 60 degrees, no? Remain angle how much it is? This is a 120 degrees, no? Here. This also it is 120 degrees. This also it is 120 degrees there. So this is a B bar we can write here, B and C. B and C, what is the angle here? We'll get there, A and B. Angle between A and B. This is a bar vector. This is a bar vector and B bar vector. So we can write here 120 degrees. Therefore, angle A bar, angle between A bar and B bar. So that is theta is equals to 120 degrees. So this will be the angle here. This is a theta there. Okay, angle between this is A bar and B bar is 120 degrees. Last one here. Which of the following is a magnet meaningful? Which of the following is a meaningful? Option A is given vector by vector, scalar by vector, vector plus vector, vector by scalar. So vector by vector and scalar by vector, vector by scalar. Which is the meaningful they are asking there? So scalar plus vector they are saying there. Put in the one. Vector by scalar we can write there. Vector by scalar. So if it is a vector by vector, we'll get the value will be 1. Scalar by vector, it is not possible there. Scalar plus vector, it is also possible. It is not possible there. The meaningful is there. Vector by scalar. vector by scalar there. So level 2 is given here. Which of the following is a null vector? So net displacement is moving in a circle. So that is the answer there. In a circular, if a body is moving in a circular path one round, then the displacement will be 0. That is the, and velocity of a body is projected vertically upward when at the highest point is 0. Velocity of person is starting from the point reach the same point. Okay, all of the above. 15th one is all of the above. 15th answer. 15th one is all of the above. Option 4. Fourth option. And here 16th one you see there. 16th one. A person start walking on the road in the morning facing sun, and after walking up for some time, he turned to my left, then walk to right once again. In which direction he is going there? So he start walking on the road in the morning facing sun, means he is moving towards east there. After walking for some time, he turned my left. He turned my left. So turned my left. Turned my left means, so he is left means he is moving towards north. Then to right once again. To right once again. Then he turned once right once again. So he is in the direction of what there? In the direction of east only, no? The direction of east. So 16th one is first option. Option 1. This is option. So 15th one is fourth option, and this one is east direction there. Now 17th one they are asking there. A person 30 meter due north, then 20 meter due east, then its displacement. 30 meter due north, 20 meter east there. So 17th solution, 30 meter north, 20 meter. So this is a 30 meter, no? 30 and 20. This is a 30 meter, 20 meter is displacement, this one. So displacement vector d bar is equal to what can we write there here? 20 I cap plus 30 j cap. 20 I cap plus 30 j cap. This is the answer. Okay. In the vector form, we can write like this. 20 I cap. This is a positive x axis and positive y axis. There is moving upward no north, towards east. So 20 I cap plus 30 j cap. Then a person moves 10 meter due south and 10 meter due west. Then direction of his displacement from the original position. So 10 meter south. So 18th one, he did 10 meter south, then 10 meter west. So it is the person is moving northwest direction there. Northwest direction there. Okay, northwest direction. Option 2. This is a northwest direction. Option 2 here. Option 2. And this is option. This is option there. 20 IK plus 10. Yes. 3. Option 3. Here this is option 3 there. So 19th one, the minimum number of unequal coplanar forces whose vector sum can be equal to 0. Okay. Minimum number of unequal coplanar forces whose vector sum is equal to 0. So that can be written as here 3 unequal forces. So the number of unequal forces, minimum unequal forces. If equal forces, 2 are enough there. Unequal forces means to equate this 19th one here, coplanar forces mean this is equal one force and the other force, and to balance this one another force is required there. So minimum number of forces should be here 3 forces, 3 unequal forces. Then F3 can be equated by the F1 plus F2 there. So now here the net force will become 0. Okay, net force will become 0 there. The magnitude of displacement in the above problem, magnitude of the displacement in the above problem is 0. So 20th is magnitude of the above problem is 0 there. So a person 4 meter due east, then due south, then magnitude of its displacement there. So due east and there due south. So next here 19th one is completed now. It is 20. So 19th one is direct question there. It is the 320 is also direct question. The displacement in the above problem is. So that is the question is not proper here. 21st. We'll see that 21st there. 21st solution. The 21st solution you see here. Person 4 meters east, 3 meter due south. So 4 meter east and south is 3 meter. This is a 4 and 3 meters. Then what they are asking here, magnitude of its displacement from original position. This is the, how much it will become 5 no? Apply here, this is a BC. Pythagoras theorem apply there, you will get that 5. Okay. So AC is equals to square root of AB square plus BC square. So we'll get here it is a 416 plus 9, it is a 25, root 25 is equals to 5. So 5 meters. So therefore the answer is here AC is equals to 5 meters. AC is equal to 5 meters there. This is the 5 meters. Okay. So this is about the vector chapter we have completed there. In the next class we are going to start kinematics. We are going to start the kinematics there. That is the last chapter. With this, we will complete this volume 1. Mostly in the next 2 problems, next 2 classes, we will complete this volume 1. Okay. Thank you, children. Have a nice day.